Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Here's a question that never comes up in a single agent demo, but breaks real systems the moment you scale. When one agent calls another, how does it know it's actually talking to who it thinks?
Okay, but is that even a new problem? Services have called services for decades.
Right, and that's the key. The answer isn't some exotic AI thing. It's machine-to-machine auth that's existed for years. What's new is the temptation to do it badly. The lazy version is, a request shows up with a header that says, I'm the billing agent, and the receiver just believes it.
And let me guess, the name in a header is the easiest thing in the world to forge.
Trivial. So think of 3 questions every single call has to settle. In order. 1. Identity. Who are you? 2. Authentication. Prove it. 3. Authorization. What are you actually allowed to do? And the magic is that those last 2 are separate questions.
Walk me through identity and proof. First, what replaces the trust me header?
A short-lived, signed, scoped credential. The standard pattern is auth client credentials. The calling agent goes to an authorization server, gets a token that expires in minutes, and presents it. The receiver checks the signature, the issuer, the expiry, the scopes. You can't forge a signature from a trusted issuer, so a spoofed name just dies, right there at verification.
And there are other flavors of that same idea?
2 more worth knowing. Mutual TLS. Both sides present certificates, so each cryptographically proves itself at the connection layer. You see that inside a service mesh. And in the A2A world, agents publish an agent card describing who they are and what they can do. And calls carry signed credentials, so a peer can verify the card really came from them. Different mechanisms, one common thread. Never a static. I'm the ex-agent string.
So that handles is this caller real. But you said authorization is a separate question. Why split them?
Because here's the failure that surprises people. Picture an agent that shows up with a completely genuine, valid token. Its identity checks out perfectly, but it asks to do something far beyond what it should. The right answer is reject it. At authorization, a valid identity is not a permission slip.
So least privilege isn't about keeping strangers out, it's about bounding what an insider can do.
Exactly, and that's the whole point of it. You give each agent the minimum scopes it needs. So if one gets compromised or just confused, the blast radius is tiny. Identity tells you who, scopes tell you what, and you enforce the what even when the who is legitimate.
Now what about an agent acting for me, a user? It needs my permissions to say, read my calendar.
And this is where the dangerous shortcut lives. You do not hand it the agent's own God mode credentials. You use delegation, an on behalf of or token exchange flow that narrows your permissions down to just this one task. So the agent borrows a thin slice of your authority, not the whole keyring.
Which brings us to the attack you've been circling. I can feel it.
The confused deputy. It's the classic multi-agent breach. A low-privilege agent can't do something itself, so it tricks a high-privilege agent into doing it on its behalf. The trusted agent becomes a deputy wielding authority it never should have lent out.
And I bet that gets nasty the second you mix it with prompt injection. Because now the attacker's instructions are writing inside text, the powerful agent reads.
That's precisely how agent systems get owned. Malicious text reaches a powerful agent, and the request's content effectively escalates its privileges. The defenses are 3 things. Verify identity on every single hop, not just the first. Pass scope delegated tokens instead of ambient authority, and never, ever let the content of a request change what it's allowed to do.
So the practical rule for someone building this?
Don't roll your own. Use your platform's machine identity, auth client credentials, and MTLS mesh, cloud workload identity, the MCP and A2A auth specs. Issue short-lived scope tokens, rotate the secrets, and log every interagent call with the identity attached. A hand-rolled API key in a header is the open door.
One sentence to carry out?
A claimed name is not identity, and a valid identity is not permission. Verify who, bound what, on every hop. That's how agents trust each other without getting played.
Cryptography over good faith. That's the Datarekha audio guide. See you in the next one.